Welcome to Homework Lib.
What will be the product in the following reaction? In a chemical reaction, the product depends on the reactants and reaction conditions such as temperature, pressure, and catalysts. To predict the product, one must analyze the reactant's chemical structures and the type of reaction such as substitution, addition, elimination, or redox. For example, if the reaction involves an alkene and hydrogen in the presence of a catalyst, the product might be an alkane. Specific details of the reaction are essential for accurate product prediction. 40. Deprotonation using LDA, lithium diisopropylamide, is a very strong, bulky, non-nucleophilic base that is very useful in selectively deprotonating a compound and forming an enolate ion. In the case of a ketone, the alpha hydrogens attached to the carbon atoms adjacent to the carbonyl group, are acidic due to the electron-withdrawing nature of the carbonyl group, which stabilizes the resulting enolate anion. The temperature here is set at -78°C, which is favorable to the formation of the kinetic enolate. The kinetic enolate forms at the less substituted, less hindered, alpha carbon because it is easier to deprotonate at lower temperatures. Formation of the kinetic enolate. Since we want to form the kinetic enolate, LDA will deprotonate the less substituted A carbon, the carbon with fewer alkyl groups attached, and thereby forming the enolate at this position. In this molecule, the less substituted alpha position is on the right side of the carbonyl group. The enolate that will be formed has a double bond between the carbonyl carbon and the alpha carbon on the right side and carries a negative charge on the oxygen. Alkylation with ethyl bromide. Once enolate is formed, it can react with ethyl bromide at 25°C. That compound is an alkyl halide, which undergoes SN2 bimolecular nucleophilic substitution with the enolate. In the SN2 reaction, the nucleophile is attacking at the carbon attached to the leaving group. So in this case, from the opposite side of where the bromine was in ethyl bromide, the bromine has left, and the ethyl group has attached to the enolate. Explanation. This results in the addition of an ethyl group to the less substituted alpha carbon on the right side of the carbonyl group because that is where the enolate was formed. Resulting product structure. The final product contains the original ketone group and possesses an ethyl group attached to the less substituted alpha carbon. Matching with the options, option 2 presents a ketone with the addition of an ethyl group at the less substituted position of the alpha carbon. This is in fact the expected product under the conditions of this reaction. Therefore, the final answer is, therefore. The right answer is option 2, because 1. At -78°C, LDA selectively generates the kinetic enolate at the less substituted alpha carbon. 2. The enolate undergoes SN2 alkylation with ethyl bromide, adding the ethyl group at this position. This elaborate mechanism assures that option 2 is the correct answer.